Hi, this is Loci from Beta Folders. Today we'll take a look at how to use the Protein Data Bank, or PDB, to find information about proteins in Foldit. And we're looking at puzzle 1520, which is a revisiting puzzle for thioredoxin, originally presented as puzzle 64 back in the early days of Foldit. And the Protein Data Bank works by the primary sequence, the list of amino acids in a protein. So we'll look at a couple of different ways to find that information. One of the easiest ways is just to click on the puzzle link, which is up at the top of the page here. So we can click on that link, and we'll open the web page for the puzzle. And then on the puzzle's web page, many but not all of the puzzles will include the primary sequence. But you can simply copy this one, and then go to the JPRED site, www.compbio.dundee.ac.uk/jpred, highlight the sample sequence that you see there in the input sequence field, and paste in the sequence that you copied from the web page. Then click Make Prediction. And for an existing protein which already has published solutions, this part is pretty fast usually. So you'll see a list of matching proteins along with their PDB IDs on this page. And if you scroll all the way down to the bottom, you'll see this button, Click to Show Hide Details. And that'll show you how well these published proteins match your sequence. Now, some of them, such as the first one here, are going to be a 100% match, while others may differ by one or more segments or residues. So you can see that 5-DQY, for example, is a close match, but it differs by one segment, one residue. So let's take a look at the 100% match, PDB ID 1AIU. We'll go to the PDB main page at www.rcsb.org and enter 1AIU into the search box. And it comes up with a suggested match, which is a good sign, so we'll click on that. And then we can see the protein's own page on the PDB. There's a lot of different information that you can see here. One thing you can do is display files and take a look at the PDB format file, or at least the header of that. This doesn't show you all the atom positions, but it shows you a lot of information. And this is kind of in a Fortran format. And if you look down here toward the end, you'll see your helixes, your sheets, and some other interesting information identified. And with a little bit of difficulty, you can change that information into segment numbers. Now, another thing you can see is the 3D view of the protein. And if you open this up, you get what looks like an image of the protein, but it's actually a 3D viewer, and you can rotate it and drag on the background. Shift drag on the background zooms in, and just dragging on the background rotates the protein. And there are various options you can pick from in terms of different views. So there's a backbone view, which is kind of similar to the trace tube view in Foldit, and several others. Licorice view shows you the side chains at least. This viewer is a little bit different than the view you'll see in Foldit. So there is another viewer available. That was the NGL viewer. There's also the JSMOL viewer. And this is more similar to the JMOL viewer that we'll take a look at in a little bit. Here, you quickly saw the atom view of the protein, but it quickly changed it into cartoon view. And if you right-click on the background, you'll see a menu which is actually very similar to the JMOL menu that we'll look at in detail later. And you can select the cartoon view, so that's Style, Scheme, Cartoon. And you can also turn on bonds with Style, Bonds. And I choose 0.15 angstrom. And what bonds actually gives you is a view of the side chains here. You can also use the JMOL viewer, which we've looked at in a previous video. Go up to the File menu, enter Get PDB, and enter the same 4-character PDB ID, 1AIU. And this one definitely starts out with the atom model, so we can go to Style, Scheme, Cartoon. And again, right-clicking on the background or shift-clicking on the background gets you that little menu. Do that again, Style, Bonds, 0.15 angstrom. So that gives you a view of the side chains. And then, somewhat similar to Foldit, there are many other options, such as under color, you can say by scheme and pick CPK, which is pretty similar to the CPK view in Foldit. So you'll see oxygen atoms in red, nitrogen atoms in blue, sulfur atoms in yellow here, and those gray atoms are all carbons. So another thing you can do is open up the console, and then there happens to be a command, background white. And that'll turn the background white. You can also use Jmol to look at ligands. For example, if you say get PDB and type in equal TYR, you'll see the model for tyrosine. And this one's already in really a ball and stick view of the amino acid tyrosine. And all the amino acids are in there, so you can say equal TRP, which will pull up the model for tryptophan, the largest side chain in our 20 amino acid bag of tricks. Some PDB models include a protein part and one or more ligands. And one example is 3-SPK, so let's take a look at that. Now once again, when we open that up, we get an atom model. So the first step that we'll want to do is switch into cartoon mode. So we'll once again call up the menu, locate style, scheme, and cartoon. So that gives us a view of the protein part of this, but there's a part that's missing too. We're missing the ligand. We're not really seeing that here. The PDB page for 3-SPK shows it is supposed to be a complex, a ligand plus a protein. So back in Jmol, a little trick with the console can help reveal that ligand. We'll open up the console and type select ligand. Okay, we still don't see the ligand, but now when we pick style, scheme, ball and stick, the ligand suddenly appears. So in this way you can have two different view options, two different schemes applied to the same PDB entry. And we can see our ligand in there. Well, this one looks a little strange. If you look at it closely, you'll see that there are carbons very close to other carbons. And so that's an indication that there are a couple of different configurations of the ligand in there. And we'll look at multiple models and multiple configurations in a future video. Some puzzles include the primary sequence on the puzzle page, but some don't. In Foldit, there are also some recipes that can get you the primary sequence in case it's not on the web page. The first recipe is called AAEdit, currently at AAEdit 1.2, and you can use the node number 102274 to retrieve this recipe. In Foldit, if you're not connected to chat, when you click on the Browse Download button, it'll let you enter that recipe number, 102274. And then just click Download. And the recipe appears in your cookbook. When you run the recipe, you'll see the primary sequence and Control-A, Control-C to copy. Then you can go to JPRED, paste it in, and when you click Make Prediction, you'll see the same list of hits as before with 1AIU as the first hit. Another recipe is Print Protein, which is currently at version 2.8, and you can get it with node number 102599. Back in Foldit, click on Browse Download again, and enter the node number 102599 if you're not connected to chat. And that will download the recipe, and then you can run it just by clicking on its name. And this recipe spends some time retrieving lots of different information about the protein. And once it's done with that, it'll come up with its initial screen. And if you're just interested in the sequence, just click OK. Then you'll get a second screen where you can copy and paste the sequence and other information. So again, just Control-A, Control-C to copy it. Back in JPRED, just paste in what you copied, click Make Prediction, and you'll see the same predictions as before. Again, 1A IU leading the list. On this copy and paste screen, you can also copy the subscores section, and that information can be pasted into the spreadsheet of your choice. So here I just go to the first cell, and I'll click paste, and that'll automatically put up an import dialog. And this is tab delimited data by default. So if you just click OK here, you'll see the detailed subscore report. Shows the total score for each segment. If you select the cell with the total score for segment 1 and then go up to Window, Freeze, you find that the row and column headers are frozen in place, and that lets you scroll through the report. Makes it a little bit easier to deal with. You can scroll up and down, and you can scroll right and left and still see your column titles and your row titles. So let's recap what we talked about. First of all, the protein data bank is good for existing proteins that have already been solved. It's not really going to help you with a design puzzle. You can get the primary sequence, the amino acids that make up the protein, in a couple of different ways. And then looking at that sequence up at JPRED is a good first step. And based on the JPRED results, you can look at the matches in the PDB. The PDB includes a couple of different 3D viewers, but you may also want to use JMOL or another viewer, which gives you more control over how you look at the protein. That's all for today. Thanks for watching, and keep on folding.